Yeah. Okay, so Clusto is a thing. So I'm going to show you how to set up a dev environment, and we'll go from there. Um, so here I have a Linux box. It has a directory. I'm in it. So first thing, git clone clusto/clusto. That's literally open source upstream Clusto. Okay, so now we got a thing. Now we need to install it. For development, I like to install it in a virtual env. Virtual env just lets you keep like all the dependencies for this thing in one spot. So you do that, you created a directory called env, and that contains things. So if you source this env bin activate, it basically, you're now inside the virtual env, so any Python scripts that execute run inside that virtual env, right? So we are going to Python setup.py install dance. And it's going to go install the dependencies and everything for you. It takes just a minute.
Only running in 2.7, right?
Yeah, it does not work on Python 3. It'll work on 2.6 probably, but it's run on 2.6. Okay, so now you have Clusto installed in a virtual env. So at this point, like, you've got the code directory and everything, but you also have a bunch of Clusto commands that you can tab complete. We are going to, okay, so the first thing, Clusto needs a database. So that's kind of important. In the conf directory, there's an example config file, the cluster.conf. Ignore the services.conf. It's kind of deprecated and not used anymore. Basically, we want to create etc clusto, and then copy conf/clusto.conf into etc clusto. Okay. This part is technically optional. You don't have to do it, but like having a config file will just make your life easier because then you don't have to think about it. So if you edit that file, you can set up the database to be whatever you like. The default is create a file called clustotest.db and use SQLite. It basically SQLite, Postgres, or MySQL work. Theoretically, Oracle should work as well, but nobody's ever tested it. So yeah, if you want to use Postgres or something else, this would be where you would do that. Also, if you were going to operate on a dump or a snapshot of the production database, you're going to need to use Postgres because that's what we use for the production database. But this works for now. So we'll stick with SQLite for now, and you can leave the rest blank, but I mean, you can see it's well commented and tells you what everything does. So now that you've got that, you just do clusto initdb, or clusto-initdb, yes. So what that did is that created this clustotest.db file here, and that is just a SQLite file, and so it's just a SQLite file that contains a database, right? So now we run Clusto shell. Clusto shell, this is basically an IPython shell. So if you've ever done Python stuff, it's an interactive Python font. Like again, print 1 times 2, and I get 2, or 2 times 2. You get the idea. So it's a Python shell, but it also has basically Clusto configured by basically reads in that Clusto config, gets the database connection set up, does all that for you, and it imports everything from the top level Clusto module for you. So like Clusto import star, it does that part for you when you run Clusto shell, so you don't need to do that. So yeah, Clusto shell is pretty cool. So what sorts of things can we do here? So the first thing you probably want to do is create a thing, because right now your database is empty. So let's create a server. So let me back up. So in Clusto, everything is represented as an entity. Entities represent things. Entities are instances of drivers. So there's like a server driver, there's a data center driver, there's a rack driver, and then entities are specific data centers or specific racks or servers, right? So you instantiate an entity from a driver. So in order to do that, we need to actually have a driver. So within the open source Clusto, it comes with a whole bunch of convenient, easy to use drivers. Basic server is the one we're going to play with. You can see you can tab complete. Pretty much all the built-in ones start with basic, so you just look at that. So we're going to create a basic server, and we're going to call it server1. Now let's call it web1, just for the hell of it. Okay, so now we have this server thing, and that's what it looks like when you print it out. Not very interesting. But now we have a server.
Question?
Yeah.
The basic zone is for the security zone. Right?
Basic zone, I believe that one was actually for like EC2 zone type stuff, but you could use, I mean, so these things are relatively abstract, right? They're just names. Most of them don't actually have any special behavior, especially within the basic classes. I'll get into that in just a minute. So let's say we want to model our data center because that's a thing that's reasonable to want to do. So we create a basic data center. Let's call it SJC1 just for kicks. So again, we've got our data center, yay. And let's create a rack too. Basic rack SJC1 A0, okay, whatever. So now I've got these things, but like they're just a bunch of like disparate objects. Like they don't have any relation to each other. So this is where container relationships come in. Basically, any entity in Clusto can contain any other entity, and then you can query on that. So for example, datacenter.insert rack, right? So now we get datacenter.contents, and it tells me, hey, this rack is in this data center, right? And then, we still know that we're looking at this data center. Cool. And you can do this as much as you like, and there's no restrictions on what types of things can be put into what other things, in most cases. So let's just follow this through. Rack.insert server. So the basic rack is one of the things that it has a little bit special behavior. It requires a rack unit as a second argument to insert. So basically, it's trying to come up with some sort of location. So let's say this is like RU20. So now we've got our rack.contents. Now notice it doesn't actually tell you where it is because rack, basically that's not well exposed right now. I'll get into that a bit later. Ignore what I just typed. Whatever. So yeah. So we've got a data center that contains a rack. So, oh god, what did I do? Hang on. So, okay, well this is good. So I just completely screwed up my Clusto shell instance. It threw some weird SQL error, so I just exited it and restarted it. Now obviously I don't have like my data center in my local scope anymore, like the basically, yeah, data center is not defined, right? So I need to get a copy of that data center object again, right? So there's this get by name method, and you give it the name of the thing, and it gives you the thing. Makes sense, right? Mm-hmm. So that should work for pretty much anything you created. Names are globally unique. No two things in Clusto can have the same name, so you are guaranteed to get 0 or 1 things. Okay, cool. So another thing to keep in mind is that all of these container relationships are bidirectional, meaning that anything that contains something, it can go in the other way too. You can see the parents of a thing, right? So the parent of this rack is the data center, and the contents are a server, right? And the rack is somewhere in the middle. Okay, so that's cool. So what if I want to see like what data center my server is in, right? So I've got like server.parents, right? So I've got server.parents tells me I'm in a rack, but I mean I would have to like kind of figure it out from the name of the rack, and maybe my rack doesn't have the data center name in it, so that's no good. So you can do search parents equals true, and that basically tells it to go and get me my parents recursively. So that's basically says okay, all of my parents, what are their parents, and then et cetera, et cetera. This returns them in a sorted order. That's kind of important because this way you can actually like go through things and figure out like how specific you want it to be, right? So this is also worth mentioning, is that anything can have any number of parents. It can be inserted into any number of things. So for instance, if I created, and this is like something you would never do, but for example, let's do. Oh, nice. So, so yeah, most things can be inserted in multiple other things. Racks have this constraint apparently that allows them to only be in one location, which makes sense because you can't have a rack in 2 places at once. But it is possible for a server to have multiple parents and be inserted into multiple other types of things. So yeah. Okay. So now we've got like some things. They're like related and they got things with them. And let's just for completeness, let's do basic network switch. Let's just call it, for example, let's call it RU1. Right. So now this rack just has a switch and the server. But again, no relation really between them. So, okay. So up to now we've seen like how you create things, how you insert things into other things, and how you query what things are in other things. Cool. You can also say, give me all of the things that are of type server. So you can basically filter the contents of a thing, right? So you say like, okay, give me all the servers or all the switches or whatever, right? So if you're only interested in one specific type of thing, you can filter it. Now what I just did, this cluster types, you should never do it that way. That's just my bad habits. There's this cluster of drivers, and you give it the actual driver object, right? So you say like, give me the server object. This is more explicit because there may be multiple types of servers, whereas this will only give me one type of server. Yeah. In the case of like our customized stuff, there's actually like a Dell server superclass that all Dell servers are members of, so you would just specify Dell server, and it would give you all the different types. Okay, so finally, remember I did the server.parents thing, show or search parents equals true. So that's doing it recursive going up. Well, you can do the same thing going down. So dot contents search children equals true. Right? And so now this is showing me all of the things in this data center recursively, which is pretty cool, right? So like this would be all the servers, all the switches, all the racks all at once. And again, I can filter this and say only give me, basic network switches. Right? So now I get all the network gear in the data center, which is kind of cool. Cool. So there's one other way to query things that's kind of really useful. It's called get entities, and it's sort of the most general like query there is. Get entities with no arguments gives you everything in the database. So this Clusto meta thing basically is just like it maintains the version of the database. You don't really need to worry about it. Just know that when you did the initdb, it created that, and you don't really need to worry about it and never delete it. But get entities, also takes the same sort of search filters as everything else. Let's do data center. So, like, I want to just get all data centers, and that'll give me all the data centers, or give me all servers. Switch, right? So get entities is really powerful. It has a lot of other options, but if you're just like, I need to just see where all the things of this type are right now, that's the way to do it. So basically the top level ones, get by name, and there's a few others here that are mostly convenient methods. Get by IP, get by MAC. You can give it a list of names, serial number. So those are also there. There is also just a very generic get method that will try to figure out what you're asking for. So like if you put an IP in here, it'll actually like it'll basically know that what you're asking for, like that's an IP, and it'll start searching by IP. Now obviously like we don't have any IPs in here yet, so it doesn't really help us. Okay, next thing. So we've talked about entities, and they have these container relationships, and so you can query them, and that's cool. But obviously you want to know more than just the name of a thing. Like you want its IP, you want its host name, you want, serial numbers, yeah. You want to know more things. So let's focus on our server object. So every entity in Clusto has attributes, or adders. So the adders method is the query method for this, and it will return with no arguments all of the attributes on the server, which by default is nothing, right? Because we haven't done anything with it yet. So let's go ahead and add an attribute. Let's do key system subkey disk value 500. Okay. So what that did is that created an attribute on this server with a key of system subkey disk value of 500. So keys and subkeys are pretty much arbitrary. generally the key is sort of like the top level name you use to group a bunch of things. The subkey is like more specific about what it actually is, and the value is obviously the value. Values can be integers, strings, or other entities. So you can actually create attributes that point at other entities. It's sort of uncommon, but it happens. So, and now again, if we query this server.adders, you just get a list of the attributes on the server. So let's add a couple more. Let's CPU count, value 14 or something that's weird, but whatever. Memory, let's say 32 gigs. Right? So now we get a bunch of attributes, right?
So data type's always an integer.
Yes. So because all of these I entered as integers. So for instance, if I wanted key system subkey, let's do like serial. Right. So I'm entering this as a string because it's got like a letter in it. Right. So now the data type is string. So basically, the key, value, and subkey are the things you're primarily going to be concerned with. And this number is sometimes used, but not always. So I'll talk about that more in a bit. And then this data type version and deleted at version, those are created automatically by Clusto for you. You generally don't edit those directly or do anything with them directly. Yeah, those are sort of an internal implementation detail that you just happen to see sometimes. So this is cool, right? Because now we've got, the server's got some attributes, and that's useful. But, let's say I want to do some configuration. Let's say, I don't know, I want to put an IP on the box. IP, let's call IPv4 value. And by the way, this is totally not the convention we use in prod. This is a contrived example. Okay, so now I got like this, actually, let me not do it that way. So this brings me to my next point. You can delete attributes, right? You don't have to specify the full attribute. Basically, it will match anything with that. Basically, if you don't specify something, then it's going to match all the things without that thing specified. So, for example, these are also the query arguments too. So if I do key IP, it only gives me the IPs. If I do key system, only gives me the system things. You can also put subkeys in here. So
like if I had an IPv4 and IPv6.
Exactly. Then you would just say IP, then you would do like key IP. Subkey like IPv4, right, would give me that, and then IPv6 gives me nothing, right? So, and you can even, you can filter on values, numbers, whatever, right? So that's pretty cool.
The nick interface also.
I'll get there. So I'm gonna actually delete that and do it slightly differently, just because of some other cool stuff that comes later. Actually, yeah, let's leave the IP out for now. So, some of the servers have some objects have convenience methods. Basically, it depends on whoever wrote the driver either added these or didn't. You can, if you tab complete this, you can see there's a lot of different things that servers can do. Obviously, there's some IP stuff here. There's some port stuff. Power, which, on basic server doesn't do anything. It's like unimplemented. I think if you I think it's just, sure, yes. It does nothing. But it should return an error. That's sort of funny. So one of the ones I want to play with here is bind IP to OS port. This is sort of the easy way to putting IPs on things. So I'm going to do this and show you how it throws an error. So IPs in Clusto are special. So basically, there are these things called resource managers, and the implementation of them is a little complicated, but you can basically think of them as an entity that counts things and keeps track of what things are used and what things aren't. So IPs, as you can imagine, they're pretty easy to count, and it's really useful to keep track of whether or not they're used. So we're going to create one, IP manager, and we're going to call this net-internal. A better naming convention would probably be a good idea. So manager, that's not what I want. So basically, IP managers have what are called properties, which for some reason don't tab complete. I don't know why, but basically it's got a base IP, which is like the network address, right? It's got a net mask, which is like, your dotted quad, and optionally a gateway. So you can say like, the gateway for hosts on this subnet should be this, right? It's not required, it's just there if you want it. So now we got this manager, and we can look, it's got some attributes already created, right? Because those property things work like attributes. You can't just like do like server.foo equals bar. Actually, you might. Yeah, so like you can see that didn't create an attribute on the server because foo is not defined as a property in Clusto. That's defined on the driver, and we'll talk about how to write drivers later. So we got this manager. Managers, you have pretty much one method you care about called allocate, and you pass it the thing you want to allocate to. So by default, that will just allocate the next available IP to this server. So now if we go look at the attributes on the server, it's got a whole bunch of cool stuff. So it's got an IP, and it's got this subkey of IP string, which is just sort of like the human readable, dotted quad. It is also storing the IP as an integer, a signed integer. So as you might know, like IPs are actually just 32-bit integers. So it actually stores the raw 32-bit integer here. It just makes doing math a bit easier. And it also stores a reference to the IP manager that allocated it, right? So and you can see this is a data type relation. This is a case of an attribute where the value is another object. So it's kind of cool. So now we've got an IP on this server. Great. So server also has like some convenient methods like get IPs that will just give me a list of the IPs. Now on the manager, like we can go back there and say like, okay, that's cool. I've got this manager. Referencers. So you can actually get a list of all the things that have IPs allocated from this IP manager just by querying the IP manager. Now, let's say you're like writing a script or something and you have an IP and you want to figure out what IP manager that belongs to, right? So there's this class method on IP manager that's basically get IP managers. Don't ever use the non-plural one for reasons. And that'll tell me that this IP manager is responsible for that IP. Now I can ask for any IP in the subnet, whether it's assigned or not, and it'll tell me that this is the IP manager for this. And if I, ask for a different subnet, then it's going to tell me there isn't an IP manager for that. Get IP managers, really cool. So now you notice that like this IP, like on the server, like it still doesn't have any relation to a port. So let's talk about ports. Whoever wrote the driver basically specifies what kinds of physical interfaces the object has. So in this case, basic server has 2 Ethernet interfaces, 1 serial, and 1 power. Power NEMA 5, that's the things you see on the wall if you didn't know that. Yeah, and you can see that this is basically just showing you, like, there's probably a better way to look at this. Maybe not. Port types. Yeah, so we'll just look at that to start. So it tells you what types of ports exist on this box, and then this port info is sort of breaking it down further, saying like, okay, what is this? What is, console serial number 1 connected to? What's the port on the other side that is connected to? Shows you those relationships. So let's go and like wire some stuff up. So connect ports, and we need to look at the help here. By the way, you can wrap help around anything, and it will just kind of give you the method signature. So we've got a port type, a port number, or source port number, destination device, and destination port number. So we've got our server and our switch, right? And switch, we can, if we look at the port info, you can see it's got a lot more ports because it's a switch. And they're all Ethernet, more or less, except for the power, and there's probably a console. No, there isn't a console, so it's a dumb switch. So we're going to connect ports NIC-ETH, because that's what Ethernet is. All port numbers in Clusto are 1-based, not 0-based. Something to keep in mind, like it's different from a lot of other things, but in network world, I'm sure you like that, because a lot of stuff in network world are 1-based. Yay, Cisco. So we're going to say ETH1 on this server is going to be connected to our switch on, I don't know, port 32. Okay. Notice we didn't have to tell it that on the switch it's also a NIC-ETH. You can only connect ports of the same type to each other, so it only asks for the port type once. So you can't like connect an SFP to a NIC-ETH, which is sort of annoying. There isn't really a great way around that right now. Sorry. So now if we look at the port info, we can see there's a whole bunch more data here. Basically, it's showing me NIC ETH1 is connected to the switch on this port, exactly what I asked for. There's also, again, like some convenience methods. We can say, tell me what's connected to NIC ETH1, and it gives me that object, right? So I can now, just from the server, say that. I can also go from the switch side, tell me what's connected to NIC ETH32, and it returns the server that I'm connected to there. So pretty useful. So now we have this like relationship established. We can query it. We can
you do
look
like
at it.
with that command?
No, but you can write a for loop. Right? And it tells you what's connected to all the things. So yeah, that's the thing to remember. It's just Python, so anything you do in Python works here too. Okay, so now we wanted to put an IP on our port, right? Because our server, we got this IP, and that's cool. And now you can see there's a couple more of these port attributes that connection created for us. Again, these are things that like you shouldn't edit directly. You should use those port methods to modify. These basically just it's basically the same data. It's just in a different format, right? Okay, so we already assigned this IP, which kind of sucks because you can't really add an IP to a port later. You have to do it when you allocate it. So let's go back to our manager, our IP manager here. So I mentioned there are two methods you care about on the IP manager. The other one's deallocate. Server, and then I want to say I want to deallocate 10.0.0.2. If you had given it, if you just leave off the second argument there, then it will deallocate all IPs from this manager from that server. So if the server had multiple IPs on the same subnet, it would just get rid of all of them. So in most cases, you'll probably just want to do that because you don't want anything. So this bind IP to OS port, like I mentioned, it's a bit of a convenience method. It basically, this is for the case where you already have an IP you know that this server should have, and you just want to assign it to this host, right? And this is also one of the kind of weird artifacts of this command is that it actually takes a system ETH name rather than a Clusto ETH name, so it's like not NIC ETH1, it's ETH0, and it's translating that into NIC ETH1 for you. Just something to keep in mind that it's sort of different because bind IP to OS port is really just a convenience wrapper around everything else we just did. And if you look at that, you can see it just did exactly the same thing, but it also added this OS port name here as another attribute. You could have done that manually, but it's kind of nice that it just kind of does that all for you in one command. It finds the right IP manager, and it assigns the IP and everything for you. And if I had asked for an IP that I don't have an IP manager for, again, it will just error out, right? So if I ask for that, it's like, hey, I don't know anything about that subnet, I'm not going to give it to you. There is also sort of an edge case. You can have two IP managers that are assigned to the same network. So, for instance, base IP 10.0 mask. So let's leave it as /16, right? So it's a different mask, but it's the same network. Totally legal to do. Because, for instance, you might have two VLANs or two data centers where you have the same IP range used in both. So it is completely acceptable in Clusto to have two things with overlapping networks. But of course, this means that now the behavior of this command is going to be extremely vague because you're not actually sure which one is going to do. So it's going to throw an error saying, I don't know how to do that. You're going to have to go do it yourself. And this is also why I mentioned you want to use the plural get IP managers because there can be more than one. If you just do get IP manager, then it's going to throw an error on you when you do that. So in general, just always write everything to understand that there could be more than one IP manager, and it's up to you to differentiate between them. So a lot of things, what they'll do is they'll do get IP managers and then just take index 0 from that list and assume that there's only one, and if it breaks, it breaks. So that's sort of like if you're just taking shortcuts. It's not good practice, but it happens a lot. So cool. So now we got our server. It's got some attributes. Cool. And it's got an IP, so server get IPs, right? Cool. So that's cool. Let's say we want to do some more stuff though, but we want to set some options, for every server in the data center. Let's say we want, I don't know, let's say we want a VLAN ID or something. So let's get our data center back here, right? Our data center has no attributes on it right now. Let's add an attribute, key VLAN. Let's not. So you don't have to specify subkey. It's just most things do. So we're just creating this attribute on the data center, key VLAN value 5. You could get much more complicated with it. Again, sort of a contrived example. But if we look at the attributes on the server, like, we don't see that. So this is where you add the merge container adders true, and that does exactly what you think it does. We're going to basically do that recursive parent search and get all of the attributes from this server and all of its parents and merge it into one set. So now I have this VLAN attribute that was set on the data center layer, or it was set on the data center, but now when I'm creating the server, I see that. So, if I wanted to be a little more specific about what I'm asking for, I can say, give me the VLAN that this server has on it. And so now any object in this data center, so I could even look at the rack, and that's still going to show up because the rack is in the data center, so the rack has VLANs, weirdly enough. But it works. So, if you go delete that from the data center, then obviously it would go away from all servers. Let's leave it there for now because it's kind of fun to play with. So you can see how that would kind of be cool. So this brings me to pools. Let's call it production. For whatever reason, pools don't have a basic word in front of them. They're one of the few things that don't. I don't know why. So pools are just like any other entity, except they don't represent a physical thing. They're just abstract concepts. And we can insert anything into a pool. We can insert our data center into the pool. We can insert our IP manager into a pool. Whatever we want. Let's do that. IP manager. Right. So again, we got our contents and we got no attributes. But now let's say, production adder. We want all production servers, Nagios, enabled, right? So now when I query my server with merge container adders equals true, I'm now going to see that I have Nagios enabled set on this server as well. Again, just that inheritance. But now if we look at our server, we've got a whole bunch of parents here. We've got a rack and a pool. So this is, again, where I'm saying you can have multiple things or multiple parents on a single thing, right? And you can have as many pools as you want on a server. Pretty nifty. There's an issue here, though, right? Because what if I set my VLAN on my pool as well? So pool or production.add adder key VLAN value 5. So my server is in both the data center and the pool. So now we have two VLANs on the thing. This is basically Clusto's way of telling you, I don't have a clue how you want to solve this problem, so I'm just going to leave it up to you to differentiate between them. So let's key VLAN. So let's say you wanted to have two things on a thing for some weird reason, and you wanted to specify them on multiple parents with the same values and whatnot. So just looking at this, you can't actually tell a difference between these two things. But if you basically print this entity attribute out, then you can actually get the thing that attribute came from. So even when you've got a list of attributes you don't necessarily know where they came from because you merged some list somewhere, you can still work backwards and get the actual things that those came from. So that said, just don't do it. Don't put two things with the same key on two parents at the same time. This is another point I should raise. It's sort of a weirdness of Clusto is you can have recursion. So you could insert your data center into your server, and now you have a loop. And this is just going to sit there and spin all day until it runs out of memory. So don't do that either. That's bad. This has got a lot of memory, so it's going to take a while. But that's at some point the Python interpreter will say you hit the maximum stack size, and it's going to stop you from doing that. But yeah, you can see if I just scroll, oh, that's not as bad a traceback as I thought it would be. Anyway, so yeah, don't do that. Also remove. It's the opposite of insert. Pretty obvious. Let's see. What else do we want to do? Okay, so that's like the very basics of core Clusto.